Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 1 to 5 of our 2017 AP Calc multiple choice practice problems, volume number 1. All right, let's take a look at question number 1. In question number 1, we're going to be assessed on how to apply the chain rule in finding the derivative of a function. Okay, so question 1 reads, if f of x equals the quantity 7x squared minus 1 raised to the 6th power, then f prime of x equals. All right, so let's go ahead and specify what our plan of attack for this problem is. All right, our plan is as follows. We're going to apply the chain rule in differentiating the function. Okay. All right, now how do we know that we're applying the chain rule here? Well, if you're asked to find the derivative of a composite function, basically a function inside a function, you know that you have to apply the chain rule. All right, so let's go ahead and take a look at what the chain rule formula is. So if you have a composite function f composed with g of x, and you want to find the derivative of this composite function, is basically the derivative of the outer function f evaluated at the inner function times the derivative of the inner function. Okay, so remember, you're differentiating one function at a time. All right, so this is our Dewey formula: derivative of the outer evaluated at the inner times the derivative of the inner. Okay, so let's go ahead and apply the chain rule differentiation formula to this problem. So let's say we have f composed with g of x. Let's just color code it so it's easy to see exactly what's going on. So we have f of g of x is equal to, the outer function is the 6th degree monomial. So the inner function is a quadratic binomial, 7x minus 1 raised to the 6th power. Okay. All right, so what we're going to do is we're going to decompose the function. Okay, the outer function is f of g of x. Let's put that in black. F of x, sorry, is the outer function, and that is x to the 6th power. And then the inner function is the quadratic binomial. That's g of x, which is 7x squared minus 1. Okay, so let's go ahead and differentiate both. The derivative of the outer function f prime of x, we apply the power rule here, so that's 6x to the 6 minus 1, which is 5. And we're going to go ahead and differentiate the inner function. So g prime of x, apply the power rule again. First term is going to be 14x, and the derivative of 1 is 0. Okay. All right, so if we apply the differentiation formula, we have the derivative of the outer evaluated at the inner, so we're going to take the inner function and plug it into the outer function and multiply that resulting composite function by the derivative of the inner. Okay, so if we do that, we're going to have f prime of x equals 6. Instead of x to the 5th power, we're going to take out x and replace it with g of x, which is 7x squared minus 1, and then times the derivative of the inner, which is 14x. Okay, so the final answer, f prime of x, is 14x. Oh wait, this is the 5th power, sorry. Okay, so 14x times 6, that's 60 plus 24, that's 84. So we have 84x times the quantity 7x squared minus 1 raised to the 5th power as the answer to question number 1. So the answer to question 1 is option letter D. Alrighty, let's take a look at problem number 2. So in question 2, we've been assessed on how to find the indefinite integral using the U substitution method. Okay. All right, so let's go ahead and go over what our plan of attack is for this problem. So first things first, you notice that there's a common factor we can extract from the denominator. So we're going to factor out the GCF. Whenever you can factor out a coefficient, factor out the numerical GCF. Do not factor out variables from an integral, please. So just factor out numbers, okay? Factor out the numerical GCF. First, that will make it easier for you to compute the integral. And then we're going to apply the U substitution integration method, okay, in integrating the integrand. All right, so let's go ahead and refresh our memory on what the U substitution formula is. So if you're integrating a composite function f of g of x multiplied by the derivative of the inner function, this can be rewritten using the U substitution as the integral of f of u du, where u is the inner function g of x. Okay, so the U substitution method is just a way to write down an integral in a more elegant fashion when the integrand is a composite function multiplied by an integer multiple of the derivative of the inner. Okay, all right, so we're integrating 1 over 6x minus 10. So if you look at 6x and 10, there's a numerical GCF that can be factored out, namely 2. So we can factor out 2 from there. So this integral becomes 1 over 2 times the integral of 1 over, so if we factor out 2 from 6x, that leaves us with 3x, and then minus 5. We factor out 2 from 10. All right, so now let's use the U substitution method. The inner function is 3x minus 5, so u is 3x minus 5. We know that that's the appropriate u because when we differentiate, we're going to get the integer multiple of the other functions. So check this out. When we differentiate both sides, the u is going to be 3 dx. So it's basically triple this function right here. Okay? We do not have a perfect match, so in order to substitute out dx, we got to have dx isolated here. To accomplish that, we are going to have to divide both sides by 3. Okay? And then we can write that as 1/3 du equals dx. So now we have a perfect match. Okay? Whenever you want to apply the U substitution, make sure you clearly have in mind what u and the other function is. So this is the u, the inner function right here. And then the other function is just dx. So dx is 1/3 du. Have that clearly specified before you start to substitute. Okay, so now we're going to substitute. We have 1 over 2 times the integral of 1 over u times 1/3 du. Okay, now we have a rational factor we can factor out, so let's factor that out. That gives us 1 over 2 times 1 over 3, which is 1 over 6, times the integral of 1 over u du. Now this is the beauty of the U substitution. Compare this integral right here to this. This is much elegant and easier to compute, right? Okay, so now let's go ahead and integrate. If we integrate that, we're going to have 1 over 6. The integral of 1 over u is the natural logarithm of the absolute value of u plus c. Okay, so we're going to resub the value of u back into our result. U is 3x minus 5. So our final answer will be 1 over 6 times the natural logarithm of the absolute value of u, which is 3x minus 5, plus c. That is the answer to question number 2, and that is option letter C. All right, let's take a look at question 3. On question 3, we are being assessed on how to apply the quotient rule in finding the derivative of a function, okay? All right, so let's go ahead and write down what our plan of attack is. So for this problem, we're basically going to apply the quotient rule. Apply the quotient rule in differentiating the function. Okay, so how do we know that we're going to apply the quotient rule? Well, if you take a look at what we have the quotient of two polynomial expressions. Okay, so we have a linear binomial in the numerator and a quartic binomial in the denominator. So if we are looking for the derivative of the quotient of two polynomial functions that are irreducible, then you want to apply the quotient rule. Okay, in certain cases you have the quotient of two functions, but just by simply rewriting it, it will be possible to avoid using the quotient rule, either by simplifying. Okay, then you can do that. In this particular case, simplification is not an option, so we have to use the quotient rule. Alrighty, so what is the quotient rule? Let's go ahead and refresh our memory on what that is. So if you have u over v, the quotient of two functions, u and v, and you want to find the derivative, is going to be vu prime minus uv prime over v square. Okay, low d high minus high d low over low low, or low square. Alrighty, so let's see what we can do here. The function f of x is given by x minus 7 divided by x to the fourth minus 1. So the numerator function is u. So let's specify that. So the numerator function is u, and then the denominator function, that's v. Okay, so if we apply the quotient rule formula, we're going to have v, which is the denominator, x to the fourth, v minus 1, so that's v u prime, so we'll differentiate x minus 7, vu prime minus u, which is x minus 7, v prime, the derivative of the denominator. Okay, so that divided by the denominator square, so that's the quantity x to the fourth minus 1 square. Okay, so let's go ahead and apply our calculus formula for differentiation. So we're going to have the quantity x to the fourth minus 1, the derivative of x minus 7. If you differentiate x, you just get 1, and the derivative of 7 is 0. Okay, minus the quantity x minus 7. If you differentiate x to the fourth, you get 4x to the third, and then the derivative of negative 1 is 0 also. Okay, and then in the denominator we have the quantity x to the fourth minus 1 square. Okay, now we're done with calculus. It's just algebra that's left. We're just going to have to simplify this completely. So if we distribute the 1, there's no change. We have x to the fourth minus 1 minus, and then you distribute 4x to the third to these two terms, so that yields 4x to the fourth. Now be careful with this minus. Okay, so this minus times this minus makes that a plus 28x to the third divided by the denominator. We're going to leave it unsimplified because in our options, if you look at the options we have, the denominator is not expanded. Okay, all right, let's combine like terms. If we combine like terms, x to the fourth minus 4x to the fourth, that will be negative 3x to the fourth plus 28x to the third, and then minus 1, and that entire expression divided by the denominator, which is the square of our quartic binomial, x to the fourth minus 1 quantity square. Let me scroll this down a little bit. Alrighty, and there goes the answer to question number 3. Let's see what letter that is. This one corresponds to option letter B. Alrighty, let's take a look at question number 4. In question number 4, we're going to be assessed in how to use the trapezoid rule or trapezoidal approximation in approximating the value of an integral. Okay, the question reads, it says the table above gives the velocity v of t meters per second of a roller coaster selected times t in seconds. Using the trapezoidal sum with 3 subintervals indicated by the table, what is the approximate distance in meters the roller coaster traveled from t equals 0 to t equals 5? Okay, so let's go ahead and write down our plan of attack here. So what we're basically going to do is we're going to approximate the integral that represents the distance using the trapezoidal sum. Okay. All right. There are 3 formulas that you want to keep in mind for this particular problem. Let's go over them real quick and then we can solve the problem. All right. So the first formula you want to keep in mind is the formula for calculating the distance. Okay, so remember, distance is different from displacement. Displacement is a scalar quantity. Displacement is a vector quantity, and distance is a scalar quantity. Okay. All right. So the distance between 2 points, let's say between 2 times intervals, let's say from A to B, is basically the absolute value of the displacement on the same interval. So S of B minus S of A, where S of t basically represents our position function. Okay, and then that's equal the integral of A from A to B of the absolute value of V of t dt. Okay, this is just FTC part 1 written using the position and its derivative velocity notation. Okay. All right, the second formula you need to remember is the formula for the area of a trapezoid. So area of a trapezoid is 1/2 sum of parallel lines times height. All right, and then in this particular problem we're using 3 trapezoids, so the trapezoidal sum with 3 trapezoids is going to be 1/2. Now since all 3 trapezoids have 1/2 as one of the factors, so we can factor it out. Okay, 1/2 times base 1 plus base 2 times height 1. That's for the first trapezoid, plus base 2 plus base 3 times the second height for the second trapezoid, and then plus base 3 plus base 4 times the third height, which is the area of trapezoid 3. Okay, so that's what we're going to be doing. All right, let's go ahead and get started. So in this particular problem, A, the lower limit is 0 and B is 5. So our distance, the distance covered from 0 to 5 is S of the position at 5 minus the position at 0. Okay, and then we'll take the absolute value of that, which is equal to the integral from 0 to 5 of the absolute value of our velocity. So this integral, notice in our plan, the first step was, the plan was to approximate the integral using the trapezoidal sum. So we're going to approximate this integral using the trapezoidal sum, okay? So it's going to be approximately T3. Now the thing about this particular problem is you notice that all our V's are positive, so we don't need to consider this absolute value. Had it been some of them were negative, then we have to alter the sign when we're looking for the heights, okay? So that's really important to keep in mind. So we don't need to keep the absolute value here. So T3 is going to be, so factor out the 1/2. Now the configuration of the table can easily help us to quickly find the sum of the parallel sides and the heights. Okay, for the sum of the parallel sides, so this is b1 b2, so we're going to just add these two to get b1 b2, and then add these two to get b2 b3 plus b3, and then add these three to get b3 plus b4. Okay, on the top you just subtract them to get, this is h1, and then subtract these two to get h2, and then subtract these two to get h3. All right, so let's specify what they are. The height of the first trapezoid is 1 minus 0. The height of the second trapezoid is 2, and the height of the third trapezoid, 5 minus 3, is 2. All right, b1 plus b2, add these two together, is 40. b2 plus b3 is 103. b3 plus b4 is 113. Okay, all right, so let's go ahead and we're gonna make use of that right now. Let me rewrite it again so it's easy to see. So this one is 40, and then this is 103, and then this right here is 113. Okay, let's do it. So we have 1/2 b1 plus b2 is 40 times h1, which is 1, plus b2 plus b3 is 103, times h2, which is 2, plus b3 plus b4, which is 113, times h3, which is 2. Okay, now we have a 1/2 here, so we can just distribute the 1/2 to everything because it will help simplify these two right here. So if we distribute 1/2 to everything, half of 40 times 1 is 20, plus the 2 cancels out with that 2, plus 103, plus the 2 cancels out with this 2, 113. If you add it all together, you get 236 meters as the distance covered. Okay, so just remember that had it been that there were negatives here, how the problem will be different is that we're just going to have absolute values for our velocities. You throw in absolute values here, and then all the signs will be positive, and then you can go from there. Okay, all right, so let's go ahead and specify what the answer is. The answer to number 4 is option letter A. Alrighty, let's take a look at question number 5. In question number 5, we're going to be assessed on how to use the chain rule to find the slope of the tangent line. Okay, or is also known as the instantaneous rate of change at a specified x value. Question 5 reads, if f of x equals tan of the quantity 2 pi minus x squared, then f prime of root pi is... Alright, so let's go ahead and write down what our plan of attack is here. So if you're looking for the SOT, slope of the tangent line, is a two-part process. So our plan is as follows. 1, we are going to find the derivative. Find the derivative using the chain rule because we have a composite function here. Okay, find the derivative using the chain rule. And then part 2 is we're going to evaluate the derivative. Evaluate the derivative at x equals 2 root pi. So remember that you do your calculus first before you do your algebra. Okay, all right. So the main formula we're going to be using here is a chain rule formula. We went over that before, but let's just recap what it is. So the derivative of a composite function like what we have here is the derivative of the outer function evaluated at the inner times the derivative of the inner function. So doidi. Okay, all right, let's do this. So for part 1, we're going to find f prime of x using the chain rule, okay? So we have f of x is equal to tan of 2 pi minus x squared. So we're going to decompose that, okay? Let's call the outer function f. The outer function is tan x. And then the inner function is g of x. And it's 2 pi minus x squared. Alrighty, so we're going to go ahead and differentiate both of them so we can apply the chain rule, okay? So f prime of x, the derivative of tan is secant square x. And then g prime of x, the derivative of 2 pi minus x squared is derivative of 2 pi. Since it's a constant is 0, so it's going to be derivative of x squared is negative 2x. Okay. All right. Now let's go ahead and proceed. All right. So the derivative of our function f prime of x. To do that, we're just going to carry out the following procedure. Derivative of the outer evaluated at the inner, so we're going to take the inner function and plug it into the derivative of the outer function and multiply that by the derivative of the inner. Okay, so let's do it. So it's going to be secant square, instead of x we have 2 pi minus x squared times the derivative of the inner, which is negative 2x. So we can rewrite that as f prime of x is negative 2x secant square 2 pi minus x squared. So we're going to evaluate for part 2. We're going to evaluate the derivative at root pi. Okay, actually it's not 2 pi. We're going to evaluate it at root pi. That's what we're doing here. Okay, so earlier we said 2 root pi. It's just at root pi. Okay, so let's do that. So let's rewrite the derivative. The derivative is negative 2x secant square 2 pi minus x squared. So we're just going to plug in root pi for all the x's. Okay, so it's going to be negative 2 root pi times secant square 2 pi minus root pi square. Okay, so simplify that. We have negative 2 root pi secant square 2 pi. Root pi square is just pi minus pi. So that's going to be negative 2 root pi secant square pi. So if we convert this into a function in terms of sine and or cosine, it's easier to evaluate. Okay, so we can use the reciprocal trig function to do this. So this would be negative 2 root pi times 1 over cosine squared pi. Okay, so what is cosine pi? You can use the unit circle or you can use your trig function. If you use your trig function, cosine pi, that's pi right there, is negative 1. Okay, if you're using your unit circle, pi is right here. Coordinates of that point is negative 1, 0. Sine is your y coordinate, cosine is your x coordinate. Okay, so cosine is going to be negative 1. So this is going to become negative 2 root pi times, okay, so you got to be careful here. Cosine is being squared, so we're going to square negative 1. So negative 1 square. So our final answer is going to be negative 2 root pi. The answer to question number 5 is option letter C. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming AP Calculus exam, do give us a like. Your positive feedback is very valuable to us. If you have any questions or comments, just post it in the comment section below, and we'll be more than glad to respond. Don't forget to subscribe to our channel. and click the notification button. We upload videos to our page on a weekly basis, so do subscribe. For access to a wide variety of resources, take a look at the link in the description below, or you can just visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.